Hello everyone, welcome to my channel. In this video we are going to discuss about Euclidean algorithm. So basically Euclidean algorithm can be used to determine the greatest common divisor of two positive integers. That is, by using this algorithm we are going to calculate that what is the GCD of two positive integers. Okay, so that is what is the Euclidean algorithm. Okay, so now this algorithm having the two steps. The first one is, now we are going to take that what are the two positive integers a comma b. That is, these two positive integers can be considered as a comma b. For these two integers of a comma b, now we are going to calculate that GCD, that is called as d. D nothing but it is the greatest common divisor of two positive integers, GCD of a comma b. Then the second step is, now we are going to divide a by b. That is, the second step is dividing a by b and applying the division algorithm. So what is the meaning here? Now we are going to apply the algorithm. We must remember that a must be greater than b. Then only we are going to apply this algorithm. So that's why dividing a by b. That means a value must be greater than b. Then only we are going to apply this algorithm. Suppose if a is not greater than b, then what we have to do? A simple solution is we have to swap the numbers. In place of a, we are going to take that b value. In place of b, what is the lesser value is there, that value can be considered as in place of b. So that is, now remember that only one rule, a is greater than b, then only we are going to apply this algorithm. Okay, if a is not greater than b, then we are going to swap the numbers. In place of a, we have to take the b. In place of b, we are going to take the a. Now this algorithm having a flow chart. So this is the very simple to understand what is the Euclidean algorithm. Okay, let us see here. Now we are going to take the two positive integers. That is where the algorithm will start by taking the two positive integers a comma b. Now as we know that what is the rule to apply this algorithm. Okay, so now assume that now we are going to take the two positive integers a comma b. Now these are the two positive integers. Now what is the rule in this algorithm is a must be greater than b. Then only we are going to apply this algorithm to calculate the GCD of two numbers. Now condition will be verified here. A is greater than b, then we are going to calculate that what is the GCD. If a is not greater than b, then we are going to swap a and b. That means in place of a, we are going to take the b. In place of b, we are going to take the a value. Okay, that is the only one condition we are going to apply here. Now if a is greater than b, then we are going to divide that a by b. That means now a can be divided with b. Now if you apply the division of algorithm, okay, that is called as divide a by b. Now you have to remember that what is a remainder. If the remainder is greater than 0, if the remainder is greater than 0, now come to here. Okay, so that is called as replace a with b. If the remainder is greater than 0, then we are going to replace a with b and b with remainder. Okay, so that is the second rule. If the remainder is 0, then the GCD of the final value become a b. If the remainder is less than 0, that is if the remainder is 0, then that value b can be considered as a GCD of the particular two positive integers. If the remainder is greater than 0, then we have to replace a with b and b with r. And then we are going to apply the division algorithm, that is called as a divide a by b. Then up to remainder is 0, we are going to apply this algorithm to calculate that what is the GCD of two numbers. Let us take the simple example to understand clearly what is the GCD of two numbers by using Euclidean algorithm. Now come to here. Now we are going to take the two numbers here. One is 710 and the second one is 310. Okay, a value is 710 and b value is, that is called as a 310. This is a and this is the b. So here as we know that the algorithm start with that is called as a two positive integers a and b. That is, what is the a value here? 710 and b value is 310. Now check out a greater than b or not. That is, what is a given condition here? The a value must be greater than b. So this is the a value, this is the b value. So now the condition will be satisfied, then apply the, that is called as a division algorithm. Now we are going to apply the division algorithm with b. Okay, that is called as b divided by a. That is, now we are going to take that 2 times of 310. Okay, the remainder is 90. Is it right? Now come here. So now here we are going to apply that 710 divided by 310. Now the remainder is 90. The remainder is 90. What is the condition here? If r is greater than 0, now 90 will come here. Okay, so now it is greater than 0. That's why what we have to do here? Replace a with b. Now this is the remainder. This is the remainder. In place of b, we are going to take that remainder 90, and in place of a, we are going to take that b. Okay, that is called as a can be replaced with b. This is the a can be replaced with b, and the remainder can be replaced with, that is called as a b. That is, b value become a and remainder become a b. So this is the next step. Now we are going to apply the division operation. So now come to here. So that is called as 310 divided by 90. 310 divided by 90. Now 93s, now we will get that 270. Now the remainder is 40. As we know that, now the remainder is again greater than, that is called as 0. That is called as a 40. Now what we have to do here? Replace a with b. Now in place of b there is a 90. It become a and remainder will become 40. Okay, so that is called as replace b with remainder. Okay, so in this remainder place, okay, so 40 is there. That 40 become a b place and 90 become a place because of the remainder is greater than 0. Now again apply the, that is called as a division algorithm. What is the next one is? That is called as 90 divided by 40. 90 divided by 40. Again we are going to get that 40 2 ja 80. Now the remainder is 10. Now the remainder is 10. Now as we know that it is r is greater than 10. Sorry, r is greater than, that is called as 0. R is greater than 0. Then what we have to do? If the condition is true, then we are going to again the replace a with b and replace or b with r. That is, now 40 become a, remainder become b. Now what is the value here? That is called as 40 divided by 10. 40 divided by 10. As we know that, now 10 4 ja 40. Now finally we will get that 0. What is the remainder here? 0. If the remainder is 0, now the GCD of the final value of b is called as a particular GCD value. So now what is the GCD value here? That is called as, what is a b place here? So that is 10. 10 can be considered as a GCD of 710 and 310. So these two values can be considered as a positive integers. For the 710 and 310, GCD is, that is called as 10. Okay, this is how we will calculate the GCD of two positive integers for by using this Euclidean algorithm. And there is one more simple way to calculate the GCD of the two numbers. Okay, let us see here. Okay, so now come here. We are going to calculate that what is the GCD of the two numbers. This is the one more another way. Okay, so to calculate the GCD of the two numbers here. Now let us take the two positive integers. One is 12, the second one is 33. Okay, so now this is another way. It is not a Euclidean algorithm. Okay, so now take that what are the divisors of 12. Okay, 1 2 3 4 6 and 12. These are the divisors of 12. And there is one more number that is called as 33. What are the divisors of 33? 1, 3, 11 and 33. Now the third step is, now what are the common divisors for these two numbers? What are the common divisors here? 1, 1, 2, no 2, there is a 3, 3 and 11, no, 33, no. So this is only we have two common divisors for these two numbers. Among these two numbers, which is the biggest number, that become a GCD of 12, 33. This is the one more method here to calculate the GCD of the two numbers. And there is one more simple example here. Okay, 25 and 150. Find out that what is the GCD of 25 and 150. The first step is find out that what are the divisors of 25 and 150. And the second one is identify the what are the common divisors from these two numbers. And finally identify that what is the maximum number. Okay, what are the that is called as the divisors of 25? As we know that 1, 5, 25 for the 25, those are the divisors of 25, and 150 divisors are 1, 2, 3, 5, 6, 10, 15, 25, 30, 50, 75 and 150. Among these numbers, the second step is to identify the common divisors from these two numbers. Okay, so there is a 1 and there is a 1. There is a 5. Is there a 5? Yes, right. 5 and 5. Is there a 25? Yes, there is a 25. Okay, now 3 common divisors are there for 25 as well as 150. Now among these three numbers, which is the biggest number? So 25 is the biggest number. Okay, so this is another way to calculate the GCD of two numbers. So anyhow, we are going to use the Euclidean algorithm to calculate the GCD of two positive integers by following this algorithm. So that is what is the flow chart is there. We have to remember this one and we have to calculate the GCD of two numbers for the given two positive integers. Thank you everyone.